All right, let's get right into it. We're talking about what is, pretty arguably, the most advanced airplane ever built, the F-35B. And this thing is a machine of contradictions. It's a piece of tech that honestly shouldn't even exist.
You know, there's a reason they call this thing a jack of all trades. The whole idea behind it was, what if we could take the absolute best parts of a few legendary planes and cram them all into one body? And just think about that for a second. They wanted a stealth bomber, a super agile dogfighter, and a jet that can land vertically like a helicopter. Those things just don't go together. Stealth needs smooth shapes, agility needs big control surfaces, and vertical lift needs just insane raw power. It's like trying to build a race car that's also a submarine. So yeah, how in the world is that even possible? How do the engineers solve this massive, seemingly impossible puzzle? Well, that's what we're here to unpack.
All right, first up, let's talk about engineering for invisibility. We're going to start with maybe the biggest challenge of all. How do you make a fighter jet just disappear from radar?
So, first things first, let's get something straight about stealth. It's not like Harry Potter's invisibility cloak. The plane doesn't just vanish. The real goal is to buy time. It's about making yourself so hard to see on radar that by the time the enemy gets a lock, it's already too late. You've already seen them.
Okay, so the number one enemy of stealth, it's something called a corner reflector. Basically, anytime you have two surfaces that meet at a perfect 90-degree angle, it acts like a perfect mirror for radar. A radar wave hits it, and bam, it bounces right back to where it came from. It's like putting up a giant neon sign that says, "I'm over here."
So how do you get rid of these radar mirrors? Well, look at a normal jet tail. It's basically one giant corner reflector. The F-35 solution is, honestly, it's brilliantly simple. They just tilted everything. The vertical tails are angled out, the horizontal ones are offset. Boom! No more 90-degree angles. The radar waves hit it and scatter in every direction except back to the source. It's a perfect example of a smart engineering trade-off. All right, next problem, the giant holes on the side of the plane for the engines. You've got two big issues here. First, the air right next to the plane's skin is messy and turbulent, and you can't let that get into the engine. Second, that big open cavity is another huge radar reflector. Now, older jets like the F-16 dealt with this using a big gap to stand the intake off the body. It worked, but that gap was terrible for drag and, you guessed it, radar signature. The F-35's solution is just chef's kiss. It's called a diverterless supersonic inlet, and it's basically this very specific, carefully shaped bump. What it does is create a pressure wave that literally shoves that bad, turbulent air out of the way. It's pure aerodynamic genius, and it also happens to scatter radar waves, and it's 30% lighter. A win-win-win. And the level of detail here is just insane. I mean, they thought of everything. Another big no-no for stealth is any kind of long, straight edge. So what do? Every single panel door, for the landing gear, the weapons, you name it, has these jagged, sawtooth edges. It completely breaks up that line for radar. And get this, they even use a special kind of tape around the edges that changes its electrical properties to diffuse any stray radar waves. It's nuts. So the outside of the plane is basically invisible to radar. Cool, but that's just part one. Now we get to the part that feels like it's straight out of a sci-fi movie. How do you make this thing transform in midair and land like a helicopter? This is where things get really wild. Just to give you an idea of the kind of power we're talking about, look at this number, 29,000. That's the horsepower that the main engine has to send through a drive shaft to a giant fan sitting right behind the cockpit. That is an insane amount of power being rerouted inside a single jet. So how does it do it in the back? The magic is in something called the three-bearing swivel nozzle. It's basically three separate rings. By rotating them, the pilot can aim all that incredible engine thrust wherever they want. A little turn gets you a 45-degree angle, perfect for those super short takeoffs, and a full rotation points it straight down 90 degrees for vertical landing. It's like a mechanical ballet. Okay, but here's the thing. If you just point that much power straight down, the plane should just tumble out of the sky. It's incredibly unstable. So, to keep it from just flipping over, it's doing a million things at once. It's bleeding air from the engine out to tiny nozzles on the wings to control its roll. It's got little vanes under that big lift fan to tweak the airflow. And of course, there's a ridiculously powerful computer tying it all together, making thousands of adjustments a second. It's what makes the hover so rock solid.
Now, you can't have everything, and getting that vertical liftability required a huge trade-off. Look at the numbers. The F-35's engine has way more raw thrust than the F-22's, but that power comes at a price. The F-35's top speed is Mach 1.6, while the F-22 can hit Mach 2.2. They had to give up some pure speed to get that incredible, game-changing ability to land just about anywhere.
All right, so we've talked about the stealthy skin and the transforming skeleton. But the real revolution with the F-35? It might just be its brain. Let's get into the electronics that turn these jets into an all-seeing hive mind.
So if you're picturing a typical cockpit, just throw that image out. In an older jet, you have a heads-up display, a little glass screen you have to look through to see your info. In the F-35, the entire display is inside the pilot's helmet. It's projected right onto their visor. It means they can look anywhere, up, down, even behind them, and all their critical data is right there in front of their eyes. And this is where it gets really, really crazy. There are cameras and sensors all over the outside of the plane, and they're all feeding a live video stream to the helmet. So if the pilot looks down, they don't see the floor of the cockpit. They see the ground flying by underneath them. It's like the plane isn't even there. They have literal X-ray vision. The awareness that gives you is just unbelievable. Now, the heart of all this seeing is the radar in the nose. And we're not talking about some old spinning dish. It's a solid block packed with 1,600 tiny individual transmitter-receiver antennas, all working together. This tech is called an active phased array radar. And what's so special about it? Well, instead of a big dish that has to physically turn and point at something, this radar can aim its beams electronically. That means no moving parts, which is huge. But the really amazing part is that it can look in 100 different directions at once, tracking tons of different targets simultaneously. It's a massive leap forward. But here's the real kicker. That radar isn't just a radar. It's also a super fast, super secure data link. What does that mean? It means a whole group of F-35s can link up and share everything they see in real time. They all see the same picture of the battlefield. So one F-35 can find a target, and a different F-35 miles away can shoot at it without even turning its own radar on. They become a single thinking, fighting unit, a true hive mind. So when you step back and look at the whole picture, you see that the F-35B isn't just a plane. Not really. It's what happens when you smash together three totally different, totally revolutionary ideas. You've got the stealth, which is all about not being seen. You've got the transformation, which lets it show up anywhere. And you have the networking, which lets it fight as a team, as a single intelligence. Any one of those things would be amazing on its own. But all three, packed into one machine, that creates something the world has never seen before. And that really leaves us with a huge question, doesn't it? For 100 years, we've thought of air combat as a duel between two amazing pilots. But what happens when it's not about the individual plane anymore? When the planes themselves can think and fight as a single, unified hive mind? What does that even look like? What's the next step in that evolution?